Thank you for being here. So today I want to talk about how Rust makes open source easier. I'm Marco. You can find me online with the handle Marco Ieni. I work at Prisma. I'm a software engineer where I build cool database tools with Rust and TypeScript. I have stickers here. Feel free to take them. And I have a podcast called Rust Ship, episode number 7, the last one. I had Ernest as a guest, and we spoke about Rust Nation, Rust London. It was great. And so I want to start with the question, what is Rust known for? And the first thing that comes to mind is performance, right? We all know that Rust is blazingly fast and so on. And it's also safe. It's way harder to get some types of bugs in Rust with respect to other programming languages. But to me, there's one more thing, and it is the tooling. So all the tools that helps Rust developers, especially open source maintainer. So the agenda for today is the following. First, I will talk about Cargo, the Rust package manager, which allows you to format code automatically, lint your code, run tests, handle dependencies, write documentation, and also a lot of community tools. Some of them allow to detect vulnerabilities and incompatible licenses, detect API breaking changes, update changelog and release your project, and install the binary on user's machine. So let's start with the demo about Cargo. So I just want to create a new library. So I will do cargo new --lib mat. And let's open this new project with the best IDE, which is Visual Studio Code. No, I'm joking. Just what I use. Okay, let's zoom in. And so we can see already that Cargo created a lot of files. So there is the cargo.toml, which is the manifest that contains the name of our project, the version, the Rust edition. There is also the cargo.lock, which contains the exact version of dependencies. Okay, stuff failing. There is gitignore, because Cargo already initializes a Git repository for us. And we have, of course, our source code. In this case, we have a library that adds 2 numbers, and it has a test. Okay, so now let's say that we want, now this project is a library. We want also to make it a binary. So we just add a new file called main.rs, and we do a main function where we can use our library function. So we do result equal mat, which is the name of our library, and then the function name. And so we can add, for example, 1, 2, and we can print this. So we do println result. And so now we want to build this binary. And to do it, we do cargo build. And this will put the binary, the resulting binary, under the folder target, debug, and then mat, which is the name of the binary. And you can see that the result is free. If we want to just run our code without doing cargo build and running the executable, we can just do cargo run. It will do the same thing for us. Now, let's say that we write some malformatted code, non-formatted code. So we do just cargo fmt, and Cargo will format the code for us. So it's not like in other languages where you need to pick a formatter from the ecosystem. Everything is built in Cargo. Also, there is a tool to lint our code. So for example, in Rust, if you omit the semicolon at the end of the expression, will return that expression. So if we don't know it, for example, and we type an explicit return, if we do cargo check to verify that there are no compile errors or warnings, nothing, there are no errors. But if we want to lint our code, and so there is an embedded linter, which is called Clippy. So we run cargo Clippy, And Clippy will show us that this return statement is not needed. So to fix it, we can just like undo what we did, or there is an handy cargo clippy -- fix flag that will fix all the issues it can automatically. Right now it doesn't work because it doesn't want to like ruin our code. So if there are uncommitted changes, it won't work. But we are brave programmers, so instead of committing, we do -- allow dirty, and it will fix our code for us. So you notice that here the return statement is gone. Nice. So if we want to run our test, again, we don't need to pick a test library from the ecosystem. We just type cargo test. The test runner is embedded into cargo, and it runs our test. And yeah, what if we want to add dependencies? So there is a command called cargo tree, which will show the dependency tree of your project. And yeah, now I don't have any dependencies. There's just my project, my library. If I want to add a dependency, I write it here in the cargo.toml, but I don't have to do it manually. I can just do cargo add, and then the name of the dependency I want to add. So let's say that we want to add a library to generate random numbers. I can do cargo add rand, and it will appear here if the network works. Otherwise, we can just do it like this. I think the latest version is like 0.8, right? Okay. Yeah, probably like we okay. I don't know. Okay. So, yeah, I don't know if it will compile because there's no network, but okay. So let's do another function. Let's call it add rand, where we want to take a number, which is an unsigned integer. We return another unsigned integer, and we want to add this number. So we want to generate a random number. So we do let random equal rand. So with rand, we call we use the random library, which is called rand, and then we can call functions. So I want to use the random function of the rand library, and we need to give it the type that we need. So I want this random number to be a useId, and I can just return the results. So num plus random. Okay. Now let's try this function from the main file. Add rand, and we run. Oh, okay, just takes one number, of course, and we run cargo run. So it will compile our library and run it. So this is the random number that we generated. So if we do cargo tree again, we'll see that now our library depends on the rand library, which depends on other libraries. Cool. So yeah, basically cargo is just downloading the rand library from crates.io, which is a registry where all the open source Rust libraries and also binaries are published. It will download the code from crates.io and compile it together with your binary, as if you wrote basically that code yourself. Cool. What I love about Rust is that you can look into the source code of your dependencies very easily. So for example, here I do command click on my function, but I can also command click on the function of my library. So here I can look at this library and I can go over and over. Here you can see the documentation of this library, which you notice is in markdown format. And the same documentation is, so here if we type rand, if we look for this library, we open it, like whenever you put your library in credits.io, the documentation of this library is rendered in HTML. So we can open here the documentation link. And yeah, we can see that here we have the documentation of the library. We can search for this function, random, and we'll see the same documentation that we were looking in the code, but rendered properly. So what if we want to add some documentation to our library? Well, yeah, we use these three slashes, and then we can say add two numbers together, and we can also have code examples. So for example, we can have let result equal mat add 1, 2, and we can assert that the result is 3. Okay. So if we want to generate the documentation of our library, we just run cargo doc, and it will write down the HTML in your file system. If you want to open this documentation directly in your browser, you do cargo doc -- open, and it will open the documentation of your crate. Here you can see the add function, and here is our example. So what happens if here I do a typo? For example, instead of, I forgot the H, for example. Well, if I run cargo test, tests will fail because cargo test runs all the examples that are in your documentation, all the markdown blocks. And here, yeah, the compiler is suggesting that we should add the H. So we run cargo test again and test pass. So yeah, it's great that in Rust, like if you have proper CI, all your code examples are guaranteed to compile, yours and the ones of your dependencies. You can also do very cool things with documentation. So for example, if we want to document this add rand function, we can say it's like the function add, but with a random number. So you can refer to other parts of your code base, structs, functions, and like you can command click to go to them. And if you do a typo and you run cargo doc, it gives you a warning. So we can see that when we generate the documentation, you'll see that the documentation adds a link to the other function. Cool. That's everything. Like when you're done with your code, you just run cargo publish, and it goes to credits.io. Okay. So this is all I wanted to show you regarding cargo. To recap, these are some advantages of cargo. You don't need any makefile or package.json scripts. All the cargo commands we saw work out of the box on all Rust programs. You don't need to check what are the conventions for the current project you're working on. And it's installed by default. So when you download Rust, all you saw it's already installed for you. So now let's go into the second part of this talk, where we discuss some community tools. The first one is cargo deny. Then we will discuss cargo server checks, release splits, which I wrote, so I'm a bit biased, and cargo binstall. Let's start with cargo deny. So cargo deny is a cargo plugin for linting your dependencies. You install it in the same way you install every Rust binary that is published on credits.io, so cargo install, cargo deny. And you add the deny.toml file to your project, and here you can specify some options. For example, if you specify a licensed deny, it means that cargo deny will tell you when your dependencies don't contain a license. Also, you can specify all the licenses you allow in your project. So, for example, if your library is GPL if your library is MIT licensed, you cannot have GPL licenses in your dependencies, and so you don't include the GPL license in your allow list, and so you're always sure that your libraries are compliant with your license. So, how does cargo deny finds the licenses of your dependencies? Well, in the cargo.toml file, you can specify a license field where you declare the license of your project, and also cargo deny parses the license files of the source code of your dependencies. So let's say that you are starting a new project called mycrate, and you run the command cargo deny check licenses. It will complain because your crate itself doesn't contain a license. So what you do is you add the license of your crate, you run cargo deny check licenses again, and you see that it complains again because Apache 2.0 is not in the licenses that you allowed. So what you can do is you go to the deny.toml file and you allow the Apache 2 license. Now, you run again the command and it works fine. So now you want to add the dependency, for example, Tokyo. And it fails because cargo deny check licenses fails because MIT is not in your allowed licenses. So what you do is you open again the deny.toml file, you add this license, and so on and so on. But at least you know that the license of your dependencies under control. Cargo deny also is able to check security vulnerabilities. So let's say that you add an old version of Tokyo, and you run cargo deny check advisories. Well, cargo deny, it will tell you that this version of Tokyo is vulnerable. It will tell you the ID of the Rust security vulnerability, a link to it, a description of the vulnerability, and the solution, which is in most of the cases just upgrade to the next version. So this was cargo deny. Now let's have a look at cargo semver checks. Cargo semver checks is a tool that scans your Rust crate for semver violations. What does it mean? It means that it prevents you from breaking your users, basically. So let's say that you have a library that contains a public function called hey, and in the next version of your library, you want to rename this function, and you call it hello. According to the semver conventions, you cannot release this library with like a minor change. So for example, if your library is at version 1.4.5, you cannot release it to 1.5.0 because there is a breaking change, and so you should release with 2.0.0. So cargo semver checks will give you errors if you don't bump the measure version. Now, let's install it with cargo install cargo semver checks, and we run it. This is the command to run the semver check, and with -p you can specify the name of the package you want to check. So this is the failure that you got. It says that a public function was removed or renamed, which is exactly what happened. So it says a pub use may have been removed, and this is the name of the function that was removed. This is the file location. So it's really easy to understand what's going on, basically. So like everybody understands that this is extremely useful, but you might wonder, how does it work? Well, it's not that difficult. Like it's a simpler trick that you might think. So we saw that cargo doc --open generates the like a description of your crate in HTML format, right? So it contains all your functions, all your structs, and so on. What if there was a format that was more easily parsable by a machine? For example, JSON, right? Well, it turns out that you, like with nightly and some stable options, stuff like that, you can generate a JSON file that represents the like basically your crate, like all your functions and so on. This file looks like this. So for example, here it says that we have the function A at this file name and this line number. The visibility of this function is public. The function doesn't contain generics, is not const, is not unsafe, is not async, and so on. So what cargo semvercheck does is it parses this file before and after you release, and it compares the two versions. It has many rules that it checks. For example, one of them is takes the function of the previous version of your crate. It compares them to the new functions of your crate, and in this case, it sees that there is a mismatch, right, between A and the law, and so it returns an error. I'm oversimplifying for the sake of time. Cargo semvercheck is a really interesting tool. I interviewed the maintainer in my podcast in episode 2, so if you want to learn more about it, you can check it out. Cool. Now we will talk about Release Please, which is a project I wrote. And I wrote it because I think that releasing a new version is very painful. And yeah, in the following I will show you what it takes to release a new version. So we will analyze all these steps one by one, starting from determining the next version. And yeah, like your library is at 1.4.5 and you decide you want to release a new version. Well, what the next version is going to be, right? 1.4.6, maybe because your new commits only are like small charts, and so you just bump the minor version, or maybe you have new features, and so you want to bump the minor, or maybe like you have breaking changes and you need to bump the measure version. But this is of course according to the semantic versioning rule. It's hard. Like you need to review your commits and determine what was going on. If you use conventional commits, it's a bit easier because you say, okay, there was a feature, so I will bump the minor version. But still, like it's painful to do this manually. After you chose what your version is, for example 0.3.0 in this case, you need to write it down in the cargo.toml, and if you have a workspace with many packages, that's painful to do. Then you need to update the changelog. One nice thing you can do is also have the link of the Git commits, like of the difference between the two Git tags, so that you see all the commits between one tag and the next one. And yeah, after you done all of this, you need to run cargo publish. You need to create the Git tag and push it to GitHub. And also, it's a good convention to create the GitHub release with the content of your changes. So, like, imagine doing this for a workspace with many crates, right? So, I wondered, are there any existing tool that solve this issue? And yes, it turns out that in the Rust ecosystem there are many tools that solve this at extremely high quality, but they all have a small thing that doesn't work for me, is that like they are meant to be run from the terminal, and instead I was looking for a way to release from CI, right? And I don't like the releasing from the terminal for different reasons. First, it's error prone. Like since it's a manual process, you might forget to run git pull, you might be in the wrong branch, like you might be even in the wrong directory. Like if there's a human involved, everything can happen. It's also less secure in some ways because you need to have the cargo token, the cargo registry token in your laptop. And so, like, what if it compromised? Instead, if you, for example, release from GitHub Actions, you just store the cargo token in the GitHub Actions repository secrets, and then you basically can forget about it. And I think it's not transparent. Like, it would be nice if your users can see exactly when you released, can see the logs of cargo publish. I think it's just nice. So, yeah, what if we can release from CI, right? And yeah, I wrote this tool called Release Splits, which allows to release Rust crates from CI with a release PR. So this is how the GitHub action looks like. You clone, like you check out your repository as always. You install the Rust toolchain in whatever your preferred GitHub action is these days, and you run release splits. You pass it the GitHub token, which is required to open the pull request, push the tag, create the GitHub release, and so on. And you pass the cargo registry token, which is required to publish your crate to crates.io. This is how the GitHub actions look like in action. And so first, like on every commit, but you can customize it, this function opens a PR that first it gives you an overview of what you're releasing. So for example, like in this case is releasing Marco test 1 from 026 to 030. And in this case, it detected a breaking change. It uses cargo semver checks, the tool we saw before, to compare the new version of your crate with the previous one. And for example, in this case, it detected a breaking change. So it gives you a report of the breaking change, and it updates the version accordingly. The PR contains some changes, of course. Well, it updates the cargo.log, and then the changelog and the cargo.toml of all your crates, as we saw in the previous screenshots. When you merge this PR, it will run cargo publish, git tag, and it will create the GitHub release. So everything is automated. Sometimes I even release from my smartphone, like I open the GitHub app and I merge this. It's cool. And it works locally too. Like you just install release please, you clone any Rust project, for example, Tokyo. You run release please update, which will give you locally the same changes you saw in the PR. So the cargo.toml, the cargo.log, and the various changelogs. Then you review these changes. For example, you might want to add more context to the changelog manually. And then you run release please release, which will do the same that would happen when you merge the PR. So locally, you can run release please release, and it will create the GitHub, publish to crates.io, and create the GitHub release. So release please is used in at least the release please GitHub action is used by 439 repositories in GitHub. These are some of my favorite projects that use release please. There is cargo generate, Tokay. And yeah, right now, release please is like this small robot that does a few things. I would like to add many features to it. So if you want to help me, reach out and we can make Rust releases easier for everyone. The last tool I want to talk to you about is cargo binstall. So let's say that you solved all these issues, so you released your project and so on. Then you still need to provide a way to your users to install your binary, right? And you can just say to your users, cargo install my project. There is one small issue, is that cargo install takes forever, right? And the reason is that cargo install will download the source code from crates.io, and it will compile it to your machine. And it takes some time. There is a tool called cargo binstall, which fixes this problem. So cargo binstall is a tool that manages binary installation for Rust projects. And the way it works is like same as cargo install. You just add the B before install. So cargo binstall, for example, cargo semver checks. And the difference between cargo install and cargo binstall is that cargo binstall will try to download pre-built binaries from of your project. So for example, cargo semver checks provide some binaries in the GitHub releases, and so I run it from my laptop. I run cargo install cargo semantics from my laptop, and it says that it downloaded the binary for so it detects your architecture, in this case Arch 64 Apple Darwin, and yeah, it says this will install the following binaries, cargo semantics. You just confirm, and the installation is very quick. How does it work? So when you run cargo install cargo semantics, it goes to crates.io, and it looks for the repository field, which is something that you can set in the cargo.toml. So this links to GitHub. In GitHub, it goes into the GitHub releases. It finds the matching one that with crates.io version, in this case v030, and it goes into the releases assets. So in my case, it found that there was the Arch 64 Apple Darwin tar, and so it downloaded, it extracted, and it put the binary in the right directory. So you don't need to say to your users, go to this page, download, extract. With cargo install, it does it for you. So it has some heuristics to find the right file. So in this case, the pattern was the name of the project, cargo semantics, and then the architecture. If you have a different, a different pattern, you can customize this in your package metadata of the cargo.toml. For example, for my project, release please, I had to change this because my GitHub releases are prefixed with release please dash. I don't know why, just the way it is. And so yeah, you can specify the right pattern of your assets. And for example, one thing I had to do was to specify that my binaries under Windows are use zip instead of tar. Okay, so first it tries to, we said it goes to crates.io and tries to download the binaries from GitHub, from GitHub releases. If it doesn't find any asset in, the correct asset in the GitHub releases, it falls back to cargo quick install. So what is cargo quick install? Is a GitHub repository which contains 16,000 releases. So in the CI, it has a cron job that fetches the most popular crates on crates.io, and it downloads them and it compiles them for all the most known architecture, Mac, Windows, blah blah, 64 bits, 32 bits, I don't know. So if, for example, if we open this semantic release cargo page, you will see that it has the binary for all these different architectures. Yeah, so basically, if you don't want to bother compiling your Rust project, maybe cargo quick install is already doing it for you, and you don't even know. So if your users type cargo install your project, they might be able to find your binary here, basically. If cargo quick install also fails, then it falls back to cargo install, and yeah, your users need to compile your project, but at least they have it. Cargo install is also available as a GitHub action. If you're running cargo install in your GitHub action, please don't, because it takes a lot of time, a lot of resources. Instead, you can substitute it with cargo install, and yeah, it works very in the same way. Okay, now you say, okay, I'm convinced. I want to publish my binary to GitHub so that my users can download it instead of running cargo install. How do I do it? There are different ways. The way I do it is I use the upload Rust binary action. You just give it the binary name and the token, which needs to have permissions to publish to GitHub releases. And like if you run it like this, it will compile it for Ubuntu. What if you want to compile it for Windows, macOS, and so on? You run a strategy matrix in GitHub Actions, for example, where you specify various targets and operating systems you want to provide to your users. I don't know, for example, Windows, Arch 64, macOS x86, and so on. And this is the result. You will have the assets in your GitHub releases. Now, it's a bit of a chicken and egg problem. How to install cargo beanstal itself? You can say your users to cargo beanstal. It's probably the last time you need to run cargo install, because then you can just run cargo beanstal to install the next Rust packages. Or they also provide some bash scripts that you can copy paste in your terminal, and it will download the binary of cargo beanstal, so you don't need to compile it. And yeah, regarding these bash scripts, we will say I will show something now. Maybe as Rust developers, we tend to believe that all our users have cargo installed, but yeah, it's not true. Like maybe if you are developing a binary, like a project that which target are other Rust developers, then you can assume it. For example, if you're, I don't know, you're developing the tools we saw, cargo deny, cargo env checks, release please, then you can assume that your audience is other Rust developers, and so cargo beanstal might work for them. But if you're developing like a general purpose application, right? I don't know, to parse logs or whatever, it's not fair that your users have cargo. So you shouldn't say to your users to cargo install your application. So if your target is wide, not just Rust developers, you should check out this project. It's called cargodist, and what it does is it populates the CI of your project with like YAML, like long YAML file that will publish your binary, again, as we saw in your GitHub releases, but it will also produce installation scripts like this one that you can copy paste to your terminal, and it can also generate a website like this where users can select their operating system and architecture. They can select how they want to install it, for example, Homebrew, NPM, anything. And yeah, that was it. Thank you. I spoke about many different Rust projects. I didn't go deep into any of them, but this was the goal of my talk. Just yeah, talk about several things, and then maybe if you like one or two, you can go deep into that. Like this was just a love letter for me to the Rust ecosystem. So a big shout out to all the maintainers and contributors that make our lives as Rust developers easier. Thanks, everyone.